Hi guys, today we're going to look at the negative ion tests, in other words, the anions. So before we did the cations, now we're doing the anions. This is the same for all the syllabi. So there's three tests you have to know: the carbonate test, the sulfate test, and the halide test. And that is the order in which you should carry out those tests for a specific reason that we will discuss. Let's start with the carbonate test. Now, the carbonate test, as you can see, is actually the same as the hydrogen carbonate test because it contains a carbonate. So we're testing for the presence of the CO3 2- ion. So what you do is you take the substance that you think contains the carbonate. So here's a solution of a carbonate, and you add hydrochloric acid, or technically any acid, to it. As soon as you add the acid, if you observe fizzing, then you have a positive test for the carbonate ion. If you want to further confirm this, you would bubble it through lime water with this delivery tube downwards, since CO2 is more dense than air, and the lime water will turn cloudy and form a white precipitate. The reason it forms a white precipitate, we have discussed before, is because calcium hydroxide is what lime water actually is. And when it reacts with carbon dioxide, it forms calcium carbonate, which is a solid, and water. This is a neutralization type of reaction because CO2 is an acidic gas that neutralizes the alkali. Now, when you answer these questions, you've got to be careful not to say that the test for carbonate is to add an acid and observe a white precipitate. That's totally wrong. Because out of the carbonate, sulfate, and halide, the carbonate is the only one that produces bubbles and fizzing. It's the only one that makes a gas. Therefore, as soon as you get bubbles, you know it's a carbonate. This here is just to further confirm there is carbon dioxide. So I would mention all of this. But just know, as soon as you add an acid and it fizzes, it's a carbonate. That's technically sufficient. Now, here are the ionic equations that are a little bit harder. They're for the carbonate with the acid. So before we did OH minus and H plus makes H2O. Now we're looking at the H plus ions reacting with the carbonate ions to make water and CO2. So that works for any carbonate: magnesium carbonate, sodium carbonate, any acid, nitric acid, sulfuric acid. Everything else will be a spectator ion that will cancel out. This is the hydrogen carbonate version, which is unlikely to ever come up, but there it is for you for completeness. The observation is fizzing, okay? And also, the solid will dissolve or disappear. So that's the observation you would expect. So with that done, we move on to the sulfate test. So the sulfate test is the one you should do next. Now, you're testing for SO4 2-. So first of all, you obviously cannot use sulfuric acid because then you'll introduce sulfate ions. Okay, so you can't do that. Now, the actual test involves two steps. Step one is to add hydrochloric acid or nitric acid. I will just go for hydrochloric. And make sure there's no fizzing. And then to add barium chloride and observe a white precipitate. That is the test. Now, let's break it down. Why should you bother adding an acid first? The answer is to make sure that there's no carbonate ions. If there's a carbonate ion, you can get a false positive test because carbonates also produce white precipitates with barium chloride. They basically form barium carbonate, which is a white solid. So to explain it further, let's just have a look at what's actually happening. The barium ions that you've introduced by adding barium chloride are going to react with your supposed sulfate ions that you're testing for to form BaSO4, which is an insoluble salt. It's a precipitate. It's a precipitation reaction, so solid. So the white precipitate is due to the barium sulfate. Now, what do I mean by removing the carbonate? What do I mean by false positive? Well, suppose that in your head you know that sulfates produce white precipitates with barium chloride. Well, imagine that you have a solution of magnesium carbonate. Now, if you don't add the acid first, if you go straight away by adding barium chloride, you'll get that double swap. So it'll form a precipitate of barium carbonate plus magnesium chloride, which is soluble. Now you've got yourself a problem, because this barium carbonate will be a white precipitate. But in your head, you think, if I add barium chloride to a sulfate, it forms a white precipitate. So you see, that's what a false positive means. It means you'll get a white precipitate, but it won't really be for what you expect. It won't be the sulfate. So that's that. If we tested copper sulfate for a sulfate, what problems might be encountered with the result? Well, the white precipitate that you get of barium sulfate might actually get stained blue, because copper sulfate solution is blue. So to make sure it's white, you could filter and wash it with distilled water to remove any copper sulfate impurity and make sure you have a white precipitate. So you should know this ionic equation. It's very imperative that you know it. Ba2 plus aqueous plus SO42 minus aqueous makes BaSO4 solid. Now we move on to the final test, which is called the halide test. This test comes in two parts again. You first add nitric acid, then you add silver nitrate. And what you do is you observe three different colors depending on whether you have a chloride, bromide, or iodide. Now, firstly, you cannot use hydrochloric acid because hydrochloric acid contains chloride, which means you're going to introduce ions that you're testing for. So you don't want to do that. Secondly, why should you add the acid first? The answer is the same as before, is to remove any carbonates, because they would just fizz. Then you wouldn't need to add a silver nitrate. The reason you do that is because carbonates can also make white precipitates with the silver nitrate. They tend to form Ag2CO3, which is silver carbonate, which is white. So that would give you a false positive for the chloride one. So after you add your nitric acid, it kind of rhymes: nitric acid, silver nitrate. The previous one was hydrochloric acid and barium chloride. You see? You could do nitric acid and barium nitrate for the previous one. Back to this one. You add your nitric acid to remove any carbonate ions that give false positive tests. Then you add your silver nitrate. And what happens is this. Chlorides produce a white precipitate of AgCl by reacting with the Ag plus ion. The bromides make a cream precipitate, which looks like this one here. And iodides make silver iodide, which is a yellow precipitate. Here you have the balanced equation. Here you have the ionic equation. I would learn the ionic one is imperative. And usually you can get away by writing this one. This one's the full one, where solution plus solution makes precipitate plus solution. So it's a precipitation or a double displacement. So if we see what's going on, you obviously can't just grab a chloride. It has to be part of a compound. So you dissolve some sodium chloride, sodium bromide, or sodium iodide first. To each one, you add silver nitrate. Add a few drops. These will swap. So it makes sodium nitrate each time plus either silver chloride, bromide, or iodide. Once again, had you not added the acid first, if you just add this and you had a carbonate, like magnesium carbonate, you'll end up getting magnesium nitrate and silver carbonate. And silver carbonate is also a white precipitate. So that'll be a false positive because you'll think it's a chloride. So in summary, these are the tests. Okay, it's 2 steps for this one and 2 steps for this one, this and this. So in a nice summary fashion, I have it for you here in the common questions and answers. So to summarize, the carbonate test, add hydrochloric acid, observe fizzing. If you want, you can bubble it through lime water. The sulfate test, add hydrochloric acid and barium chloride, and you get a white precipitate, which is BaSO4. And the halide test, add nitric acid and silver nitrate, making sure there's no fizzing, and observe either a white, cream, or yellow, depending on chloride, bromide, iodide. So they're like directly below each other in the periodic table. Chloride, bromide, iodide, white, cream, yellow. Get used to the rhyme. That completes the anion tests. Lastly, you should also know the chemical and physical test for water. So the chemical test for water we've seen with reversible reactions, and we'll see it once again. You add white anhydrous CuSO4, and it will turn to blue hydrated copper sulfate, which is CuSO4.5H2O. That confirms that you have water. It doesn't confirm the water is pure, but it confirms that you have water in a chemical way using a chemical. This reaction is looked in more detail in the reversible reactions topic. Lastly, the physical test for water, for pure water this time, to make sure it's pure, is you simply boil it and check the boiling point is exactly 100 degrees Celsius, or you freeze it and check the freezing point is exactly 0 degrees, because impurities would lower the freezing point and increase the boiling point. With that, we have now completed the chemical tests. If you do AQA, tune in for the extra lesson on flame emission spectroscopy. Otherwise, that's it for now. Thank you.